Alrighty, binomial distributions in less than only a few minutes. So what do we look at for binomial distribution? Binomial distribution is when we've got trials, but that's a fixed number. We want to know the number of successes. This is variable, it's what we calculate. So for the binomial distribution, we need the total number of trials and a probability with which we may gain a success. So in this case, do you want to have a crack and pause the video about what's the number of trials that we have? And then what's the probability of success? And which is E. And pause the video now. Cool. All right. So when we calculate these distribution functions, remember it's kind of like brute force / just a lot of trial and error. You want to know what the what's the probability, how is that probability distributed? So, you might say that, 3 times that many, you might expect 39 buffalo to have foot and mouth, but what's the chance that there might be 20 buffalo with foot and mouth? Or what's the chance that maybe that's 40? And this is where the distribution of risk is really helpful. Cool. So let's punch this in. So the X is going to be our number of successes, which in this case is the number with foot and mouth, which is success. And this is where we put the distribution function. So let's go up in, let's say 5s and see what happens. Cool. So let's just do a bunch. Let's go to 80 because we can always do more later. So let's have a look at the distribution function. Go equals binom dist. Remember, you press tab, the number of successes. Remember, this is what's going to be variable in what we're testing for. So click 0 or click that box and that'll run us down. Comma, number of trials, that's fixed. And that is how many? 1300, very good. What's our probability? 3% or 0.03, very good. And we want it to be cumulative, yes, and we'll run through that in a sec. That'll be a little add-on if you like. So let's fill this table up. So basically this number here is the probability that you will have no buffalo with foot and mouth disease in that group of 1,300 when the prevalence of foot and mouth disease is 3%. So incredibly unlikely. And then as you can see, the risk goes up. So the risk of having 25 or fewer buffalo with foot and mouth is about 1%. But let's plug this in on a graph. So you select all of it, you go up to insert your recommended charts, or I just use a scatter plot. You can also use a histogram, that's okay too, depends what your lecturer wants. Let's rename some of these things. Let's get some away. Prevalence of foot and mouth disease in buffalo from Kruger National Park. Go away. Let's add some axis titles. This is the number of buffalo infected, and this is the probability. And you can change this as well to make it better reflect between 0 and 1, because remember, our probabilities only go between this amount. Oh, that's had a little bit of a glitch, hasn't it? There we go. So and I forgot to put the naming convention in. Always make sure you do that. So binomial, and the convention, remember, is n, p. So n is what? 300, very good. And p is what? Very good. So virtually you'll have the risk, hang on. The number of buffalo infected will probably be somewhere between 25 and 55. but we can more specifically get into numbers. So let's have a look here. So there is a 99% chance that the number of buffalo infected will be 55 or fewer. There is a 60% chance that the number of buffalo infected will be 40 or fewer. And then if you wanted to give a specific range, you can actually just subtract them. So for example, what's the probability that the number of infected buffalo is between 40 and 50? You would just go the probability of this one minus the probability of that one. So like a 36% chance that the number of infected buffalo will be between 40 and 50. So that's the way you can calculate that. Good. Any questions? Post in the box. Bye.